everyone, welcome to Epsilon Pro Academy. In today's lesson, we are going to be dealing with application of differential calculus, and specifically, we will be talking about equation of a tangent and normal to the curve. In our previous lesson, we talked about the gradient of a tangent and also the gradient of a normal to a curve. Let us recall that from our previous class, the gradient of a tangent to a curve was given as gradient of tangent was given as m1, and we stated that this m1 is equal to dy over the x at a point AB. At a point AB. Now, if we are relating this to the equation of a tangent to the curve, then the equation will be given as y minus y1 is equal to the gradient m1 in bracket x minus x1 bracket close. This is what we call the equation of the tangent. This is equation of the tangent. Also, from our previous lesson, let's recall that the gradient of a normal to the curve, gradient of a normal to the curve was given as n2 is equal to minus 1 over dy over the x at a point, let's say A, B. Now, if you are comparing this to equation of the normal to the curve, then the equation becomes y minus y1 is equal to m2 in bracket x minus x1. So this becomes the equation of the normal to the curve. Now note that m2 is minus 1 over the y over the x at point AB, whereas m1 is the y over the x at point AB. So let us consider some of the examples under equation of a tangent and normal to the curve. The question says, find the equation of tangent and normal to the curve. Y is equal to x raised to the power of 3 minus 2x raised to the power of 2 plus 3x at point x is equal to 1. Now note that when it comes to equation of a tangent and normal to the curve, sometimes the equation could be given to you either as an implicit or explicit function. What is given to us on the board is an explicit function. Now the concept is that whether it is implicit or explicit, the first thing we have to obtain is to find dy over dx. That is, we have to differentiate first. After differentiating, we determine what is called the gradient or the slope to the curve. And to do this, the function is y is equal to x raised to the power of 3 minus 2x raised to the power of 2 plus 3x. The first step, dy over dx, or to differentiate. If I differentiate this function, then my dy over dx will equal to, the concept is that multiply this power by this term, that will be 3x, then subtract 1 from the power, it becomes 2 minus, over here, multiply this 2 by this term, it becomes 4, x, then subtract 1 from 2, it becomes 1, plus, if you differentiate 3x, it gives 3. And that is dy over dx. Now, from the question given, we are required to determine two things: tangent and normal to the curve. So let's start with tangent. Let's begin with tangent. To determine the equation of the tangent, we have to determine the gradient of the tangent. So the gradient of the tangent, it is m1 is equal to dy over dx at a point where x is equal to 1. Where x is equal to 1. That means I am going to substitute 1 in dy over dx. Put 1 into dy over dx. So since x is given as 1, I'm going to replace this x by 1, replace this x also by 1. In that way, I will obtain the gradient of the tangent. So gradient of the tangent m1 will equal to 3, bracket open, x is 1 raised to the power of 2 minus 4, bracket open, 1 plus 3. So m1 is equal to, this raised to the power of 2 is 1 times 3 minus 4 times 1 is 4 plus 3, and m1. Now the gradient of the tangent is equal to 2. Up next, at x is equal to 1, from the question given, let us determine the value of y from this function. So y will equal to x, which is 1 raised to the power of 3 minus 2x 1 raised to the power of 2 plus 3 times 1. Y is equal to 1 minus 1 raised to the power of 2 is 1 times 2 is 2 plus 3. 1 plus 3 is 4. 4 minus 2 is 2. So y is equal to 2. At this point, y is 2, x is 1, and the gradient of the tangent is equal to 2. Let us record that. The equation of tangent is given as y minus y1 is equal to m1 x minus x1, x minus x1. So y, let's substitute. y1 is given as 2. So we got minus 2, which is equal to m1 is the gradient, which is 2 in bracket x minus x1 is given as 1 on the board. 1. So y minus 2 is equal to, expand the bracket, 2x minus 1. Y is equal to 2x. When this minus 2 crosses over, it becomes plus 2. And plus 2 minus 1 is equal to 1 plus 1. So the equation of the tangent is equation of tangent is equal to y is equal to 2x plus 1. We have obtained the result in the equation of the tangent. Up next is equation to the normal. Now, before we can get the equation to the normal, the first thing we have to obtain is that we must get the gradient of the normal before obtaining the equation to the normal. Now, let's record that the gradient of the normal, M2 is given as M2 is equal to minus 1 over dy over dx at a point where x is equal to 1. Since that is so, that is to say M2 will equal to minus 1 all over at x equal to 1, dy over dx gave us 2. That means M2 is equal to minus 1 over 2. Minus 1 over 2. That means the gradient of normal is equal to minus 1 over 2. Let us record that equation of normal to the curve is given as y minus y1 is equal to M2 x minus x1. Now note that x1 is equal to 1 and y1 is equal to 2, which has already been determined from our previous solving. So from the substitute, y minus y1, which is 2, is equal to the gradient of the normal is minus 1 over 2, bracket open, x minus x1, which is 1. Okay, y minus 2 is equal to, multiply this by the bracket and we obtain minus x, multiply this by this, plus 1 all over 2. Let's cross and multiply. Cross multi. By cross multiplication, to be this times the denominator, that is 2 in bracket y minus 2 is equal to x plus 1. And we have 2y minus 4 is equal to x plus 1. Collection of like terms, 2y, when x crosses over, minus x is equal to, when 4 crosses over, it becomes plus 4. Then plus 4 plus 1 gives 5. 5. And this is the equation of the normal. So the question was, find the equation of the normal and tangent to the curve at this function at a point where x is equal to 1. So equation of the tangent is given as y is equal to 2x plus 1, and the equation of the tangent, normal to the curve is equal to 2y minus x is equal to 5 respectively. And that becomes the final result. Now let's consider another example